Okay, so this one's tricky to people. And so it's common. Expect it to be tricky for you until you get comfortable with it. I want to say that in chapter 1, just go through it. It doesn't have to be perfect because you keep going. We're going to keep using this. And eventually you'll just be familiar with it and go, why was that so hard? Yeah, I mean, we all have that experience, especially with physics. Remember, we're talking about times. So, for instance, when I did an object here, and I said velocity 1 was here, well, that was at a certain time 1, and I called that state 1. If over here this was state 6, and I said that's velocity 6, that happened at time 6. This is the velocity, the speed and the direction, the speed and the direction at that time. And of course it could have position x1, x6, and so on. And you'll see the situations. So you just lay the puzzle pieces out. Really, a lot of the work is done reading it, visualizing and sketching, choose which way you're going to call plus, and label the variables, and then it'll come out pretty nicely. So we're building on this. People don't realize it. Often they don't know why they can't do the physics problems, because they're not doing this. It's not just math. It's not just math with units. It's thinking about a physical process and developing an awareness of some concepts that are rather tricky. But you can get them. They're not so tricky if we break it down. So acceleration is the last thing in describing motion. We've got time, change in time, interval of time, position, displacement, sometimes distance, velocity, speed and direction, and acceleration. Boom. And that'll cover us all the way through chapter 5, those ideas. So we're going to be working on this with good notation. It'll build up. Acceleration is tricky. Acceleration is not velocity. You can have a high acceleration, and often do when you're going slow. You can have a low acceleration when you're going fast on the freeway, because how much acceleration is how abruptly you change your velocity. And on the freeway, when you have a high velocity, you don't want to change abruptly. That's dangerous. If you're going slowly, well, you can hit the brake or hit the gas. You can have an abrupt change with a slow velocity. If you have a high velocity, you often want to have a small, gentle acceleration, increasing speed, decreasing speed, or turning. And oftentimes when we're turning, we're first decreasing speed and then increasing speed. So that's what acceleration is, and you'll get used to how much and think about it a little bit so it'll mean something to you. The direction is tricky. So we're just going to look at 1D motion right now. I'm just going to do forward and backward. You'll do up and down and a lot of things. If you're increasing the speed, then the acceleration is the same direction as velocity. And let me put this here, not necessarily positive. It could be negative. Okay, so that's often, sometimes people teach it this, they say, oh, you're increasing speed, positive acceleration. They're trying to make it simple. They're making it more confusing because you're always going to make some, or you're going to often make mistakes. If you're decreasing speed, the acceleration is opposite the direction of the velocity. So we'll get used to just accept it. Some things, and I had a hard time, I had to learn this, some things you just got to accept and go with it. And then you'll get used to it and it'll start making sense. But this is not necessarily negative. Let's take a look. So the situation I'm going to use here is one where I'm, say, in a car, whatever, running. We start from rest. Don't always have to start from rest, but here we will. Then we're going to increase speed. Then we're going to keep the same speed. Then we're going to decrease speed. And we're going to stop and have that cappuccino. Sit there for a while. Then we're going to increase speed, keep the same speed, decrease speed. So that's what we're going to do. All right, let's take a look at that. And
Oh no, just looking around.
okay, So let's say, and we could choose any direction because we can do up and down. We could talk about that pen as it goes up and down, etc. So I'm going to do it this way. I'm going to start here. And I'm going to put the state number 1. State 1. Now remember, it could be moving when you start it, but I'm going to say it's not. So I'm going to go ahead and say V1 is equal to 0. And that's time 1, position 1. Velocity and acceleration, we'll see. Now, if you're just sitting there waiting for the light to turn, I could say T1 is whatever time, the velocity is 0. If you're just sitting there, you could also be there at V2 is still 0. So that's at time 2. I don't know, so that's 1 and 2. It's getting kind of messy when you're sitting at a stoplight. But then when the stoplight's there, you still have to start from rest and build your way up. So now I'm going to go faster and faster. And so as I go to here, I'm going to go this way. I'm going to label that V3 now because I got all these states. This is a little crazy, but so while I'm going this way, I am increasing speed. But then, sure enough, there's a stop sign or a stoplight that you might have to decrease speed. But let's keep the same speed for a minute or whatever time. 4. So I'm going to try it kind of the same. V4. And then let's decrease speed. And let's decrease speed down to a stop. V5 equals 0. But maybe we're turning around, and the only way I can turn around is to stop. And I could stop at an instant, I could bounce. Even something that bounces stops and then comes back. I don't know, so let's say we bounce. I don't know, we're in a bumper car. If we bounce, then what we often say is we are at 0 and then we go increase speed. Maybe I'll increase speed a lot. Times 6, I have V6. And then maybe I increase speed even more. I'm going to go farther. And let's say I decrease speed, V8. Okay, and so in here, I'm going to decrease speed. Now that's what's happening. That's my video, that's my car, that's how I do it. And the velocity tells you which way I'm going, and I've kind of described the process. But where's the acceleration? Acceleration, from 1 to 2, you're sitting at the stoplight. You're not changing your velocity. So acceleration from 1 to 2 is 0. This is 1 to 2, you're sitting there. And again, we get mixed up on our head because there's so much going on. And we often have to rethink it and catch our mistake. But okay, so from 2 to 3, I'm increasing my speed. Now that means that the acceleration is in the same direction as velocity. So I can do this as an arrow. That means I'm increasing my speed from 0 to V3, A 2 to 3. How much depends on how hard you step on the gas pedal or whatever. So I can draw it longer if it's more abrupt and shorter. We don't have to make it too precise. But since I've increasing the speed, the acceleration is the same direction as the velocity. Now I keep the same speed. So I'm moving, but I'm not changing speed. And so A 3 to 4 would be 0. And then I decrease speed. And decreased speed, acceleration is opposite direction of velocity. A 4 to 5 is this way. However, abrupt or gentle will tell me how much, and these will be variables and we'll solve them algebraically for how much and things like that. But that's opposite. And we'll talk about this in a second. Now, if you just go like that, kind of bounce, so sort of at an instant, and there's interesting things there. And we're going to go from this speed and direction, stop, and then go this. From here to here, I'm increasing speed. Now watch this, from 5 to 6. Going to the left means I'm decreasing speed because it's opposite v. Going to the left means I'm increasing speed here because I'm going in the same direction as v. And I keep increasing speed, then I got more A 6 to 7, 7. And if I decrease speed here to here, then I go A 7 to 8. So wherever I'm in the same direction as velocity, you're going to add on some speed here. Nothing means you're going to keep the same speed. Opposite the velocity means you're decreasing. I'll say this a few ways. From here to here, and then from here to here, you're increasing, same as v. Decreasing, opposite v to the left. Increasing with v to the left. Increasing with v to the left. Decreasing, opposite v to the right. Couple of things here that you can totally get, but they're confusing at first. And often we get confused because we have to learn it so fast. And number one, plus minus. If I call that plus x, then that's positive for increasing speed. That's 0. That's negative for decreasing speed. But now that's positive. No, it's not. Oh yeah. Oh, I got messed up in my head. I got to make sure I check because you're going to make that mistake. Your increasing speed, isn't that positive acceleration? No, because positive's to the right and this is to, I'm increasing speed this way. That's got to be a negative acceleration, increasing speed with the velocity. That's all that matters. To the left, which is I call negative, increasing speed with the velocity. That's what matters. Plus or minus just depends on what you do here. Now, decreasing speed, it's in the plus direction. Opposite v means decreasing speed. Plus or minus just has to do with this, because if I say, hey, I don't like that, I like this. Now left is positive. Increasing speed negative, 0. Decreasing speed positive. Increasing speed positive, increasing speed positive, decreasing speed negative. I just have to look. So this is your choice. It could be flipped. You and I could say plus or minus opposite. But this is always true. If it's increasing speed, acceleration is in the direction you're going. We won't worry about turning right now. Decreasing speed, these are opposite. There's one other way to, well, two other ways to understand this. They're related. And that'll be it. So just go with that. Follow that and scratch your head and do some stuff. And once you smooth it out, that's very substantial because that haunts people. And then you just go to the algebra and you stop thinking about the physics. We don't want to do that. That makes it hard and you always mess up. How do I think about that? Think of this acceleration as adding to or subtracting from the velocity. If it's with the velocity, it's like it adds more to the velocity. Actually, acceleration times time is going to add to the velocity. Another way of thinking of it is to accelerate something, if it's going this way, and if your friend's on a skateboard, you push them that way. That is like a push. In chapter 8, 7, and 8, I really sort this out. Acceleration doesn't, you maybe don't worry about this too much, but acceleration doesn't change your velocity. It's just describing what's happening. The reason is somebody pushed you, or whatever. If you push them this way, they'll increase speed. If you push them this way, they'll decrease speed. Now they're going this way. If you push them this way, they'll increase speed. If you push them with the motion, whichever place, with the motion, right, left, they'll increase speed. If the acceleration is with the motion, it'll increase speed. If it's opposite the motion, it'll decrease speed. Opposite is to the left here, opposite is to the right here. So if you think of it as coming from a push, you'll know which way to do it. And for now, that's fine, because we'll build up the algebra and we'll put it in, and it won't be as many steps as this actually. It's pretty complex. But we'll keep track of it and avoid those really annoying mistakes. So, do you have any questions? Like, you think, come on.
I think I got it now.
You think you got
Yeah.
that? Yeah, it really is tricky. I'll throw this one in just for a bonus. If an object goes up, and I'll tell you why I say increasing speed and decreasing speed. We usually say speed up and speed down, but watch. When you throw a ball up, it's going up, but it's slowing down. It's like, but I'm going up, slowing down? No. You could say I'm going up and decreasing speed, and then go like there. And then as it goes down, you're speeding up. So as you go down, you increase speed. At the same place, you'll have the same speed as long as the air resistance isn't too much. And then I'm decreasing speed, so acceleration has to be opposite. And here I'm increasing speed, and acceleration has to be with. And even at the top, you are changing. It doesn't just sit there and have cappuccino. So it's the acceleration is down the whole way. Why? Because we think of gravity as pulling down the entire time. And that confuses people because we don't have time to pause and have a cappuccino and think about it. So have a cappuccino and get this straight. Do the exercises, work them out, and just keep moving forward, even if some things are a little fuzzy, because it'll start coming together and be very familiar and comfortable for you. So here's to your success.